Hi, everyone. If you're just joining, you're welcome. Longest time, guys. Sorry, I'm trying to set something with my other phone. So, hope you all are doing fine. Hi, hi, hi. If you're just joining, you're welcome. This particular phone had a network. Say something. Guys, it's been a while, right? Hello. Can we 8 people on board? All right, guys. So, welcome back to my live stream. Today, I want us to discuss an important topic, and that is Pascal's triangle. Students find it difficult to students find it difficult, yeah, but it's actually um the easiest so far. Yeah, let me put it that way, because when it comes to using Pascal's triangle, it's more or less like, yeah, Sheriff, you're welcome. It's more or less like you're already on what to do. Let me put it that way. So, you are all welcome, you are all welcome, you're all welcome. The Pascal's triangle. So, if you are just joining, you are welcome. If you are just joining, you are welcome. You missed me, right? Trying to make sure things are going well. So how is the view? Can you see the board very well? Can you see the board very well? And can you see the write up very well too? So let me try to write something. The topic anyways. Can you see the board very well? Okay. Side down or something. Let me try to remove the mirror. Okay, I think it's okay now, right? Yeah, I think it's okay. So we'll be talking about the Pascal's triangle. We'll be talking about the Pascal's triangle. Now, Pascal's triangle is actually used for expansion of algebraic terms when those algebraic expressions, the power is high. This is what I mean. For example, for example, if we are asked to expand a plus b raised to the power of 2. a plus b raised to the power of 2. Okay, this is actually very easy to expand because we can do it in so many ways. We can decide to do it like this: a plus b multiplied by a plus b. Okay, a plus b multiplied by a plus b. All right, I'm so sorry, I'm trying to find a way to see your comments and your everything, so that is why it seems I'm looking at a particular spot. Okay, so like I said, we can expand this in this way, that is a plus b multiplied by a plus b. Then we can expand this. Expanding this is very easy. So it's going to be a multiplied by a plus b, then plus b multiplied by a plus b. So we are going to use a to multiply a plus b, and we are going to use plus b to multiply a plus b as well. You understand? Then we go ahead and solve this, which is very easy. A multiplied by a will give us a squared. Okay, so we have a squared. Then a multiplied by b will give us ab plus ab, because we have plus here. So we have plus ab. Then plus b multiply a will still give us plus ab again. And plus b multiply plus b will give us plus b squared. So if we solve this further, we are going to have a squared plus 2ab plus b squared. Now this is one way this particular algebraic term, or if you're already conversant with its identity, the algebra identity of a plus b squared is very easy: a squared plus 2ab plus b squared. If you actually cram that one, do you understand? All right, now we use Pascal's triangle. Assuming you are now asked to solve a plus b raised to the power that, like, if you are asked to do a plus b raised to the power of 4, how will you go about it? So this is where the Pascal's triangle comes to play, because if you are asked to do it, that means you need to multiply a plus b multiplied by a plus b multiplied by a plus b multiplied by a plus b. Then by the time you finish this, which will take you a very long time, okay, because we are humans, we are not robots, neither are we computer, we are humans, so we are bound to make mistakes somewhere. So I will explain in detail everything you need to know about the Pascal's triangle. Okay, so we are going to start from how to draw the Pascal's triangle, or how to generate the Pascal's triangle. Okay, all right, let me check your comments. Thank you, Alex. Thank you. Lawrence, you are welcome. Please, your camera is not stable. Not stable, how? Please let me understand what you mean by that. Someone said my camera is not stable. What actually is wrong? Is it that you cannot see the camera? You cannot see the board clearly, or what? Please, I need confirmation on that. How is my camera? Please let me know. How is my camera? Confirm how my camera is. How is the view? How is the view of my camera? Let me know, please. Your camera is the board clearly. Oh, okay. That means maybe it's coming from my network. maybe it's coming from my network. Another person should confirm, please. The screen. Okay, the screen is what's happening to the screen. It's to the screen, please. But can you see what I'm writing? Can you see the write-up clearly? That is the most important thing. I know you cannot see the whole board. Yes, I know about that, but my write-up, can you see it clearly? I need to know, please. It's blurry. Ha. Why is it blurry? Is it that it's network or what? Please, I need more confirmation. Not all. You cannot see everything that I write. Okay, that then I will need you to confirm for me how the whole thing is, if you can see the write-up very well. Now, for the Pascal's triangle, okay, in order to deduce the Pascal's triangle, yeah, I'm a family. That's what I'm doing now. You first of all write one, then you write one and one again. Okay, then this one, then you write one and one again. Then you add this together. 1 plus 1 will give you 2. You are forming the third line now. Now these two will be in the middle of these two lines. These two numbers you added together. You are meant to write it in their middle. Okay? Then, having written that, you need to complete this with another 1 and 1. Okay, so you write 1, then you write 1 and 1, then you add this to get 2. Your 2 must be in between this. You are forming the third line. Having done that, you write 1 and 1 because there's nothing to add again here. Now this time you continue to the third line. Muhammad, you're welcome. The fourth line, sorry, because this is the first line, this is the second line. Now we are on the fourth line, right? This is the third line. So you add again. So 1 plus 2 will give us 3. 2 plus 1 will give us 3. You can see that I'm writing each of them in between the two numbers that I added together. Alright? So 1 plus 2 is 3, and 2 plus 1 is 3. Then I'm done because there's nothing to add here again. I will complete this line again with 1 and 1 again. I hope this is clear. Alright, now I want to confirm. Can you see what I just wrote clearly? Because this is going to confirm if the board is blurry or clear. Your voice is clear, but vision is not clear. The writing is not. Muhammad Diris, can you confirm for me? Can you see the board clearly? Because at this point, I'm somehow I don't know what to do. That means my network is poor. So should I you can see the board clearly. That means it's not voila. That means this is not for everybody. I don't know. So let me just continue. Maybe okay, you can see the board clearly. So where is this coming from then? Where is this coming from? Or is it the camera? Is it not well cleaned or what? Whew. Okay. So I think what I need to do now is simple. I'll just try and finish today's lesson. Then in our next live class, I will find a way around the whole thing. Okay. Okay. Now, if you look at this particular one, we have formed the fourth line. Now, to form the fifth line, we add again. 1 plus 3 will give us 4. 3 plus 3 will give us 6. 3 plus 1 will give us 4. Then you complete the line with 1 and 1. This is the fifth line. Now I'm going to stop with the sixth line, because I'm not going to, whatever we are going to solve today will not pass the power of 5. So if you want to expand the knowledge, you can then decide to expand your own to maybe power of 6, power of 7, power of 8. So I'm just going to stop at power of 5, which will be the next line. Okay, so just watch closely. This is very, very easy, like I said. So to form the fifth line, 4 and 1 plus 4 will give us 5. 4 plus 6 will give us 10. 6 plus 4 will give us 10. 4 plus 1, let me increase the 1. 4 plus 1 will give us 5. We are done. Notice that there's nothing to add again. There's nothing to add again. So like I said, I'm going to stop at the fifth line. Now, these are very important. These numbers you are seeing on each line, they are very, very important, depending on the power of the algebraic expression. Now, for example, if you are asked to expand, a plus b raised to the power of 3, then we are talking about this fourth line that has 3 as its second number. This is not regarded, okay, except if you are given anything raised to the power of 0 is 1. So this is for power 0, which is not needed, because once this is consigned, the Pascal's triangle comes to play or helps us when the power is high. So when the power is 0, we don't need it. We already know that any number raised to the power of 0 is 1. Then when the power is 1, we already know that we have the same thing. So it's important, we actually need from this down. Now a plus b to the power of 3, that means we need this one, this particular line. Okay, now the coefficients are 1, 3, 3 and 1. 1, 3, 3 and 1. So the question now is, how do we use it? Okay, how do we use these coefficients, because this forms the coefficients of our expression. Okay, so I'm going to clean everything now. Then number 3 is 1331. So I'll write it out. This is what we are looking at, 1331. These are the coefficients we are looking at. Okay, so I'm going to clean the Pascal's triangle, believing that by now you should be able to deduce that by yourself. All right. Okay, so this is the third line, 1331. Now, how do we make use of it in expanding this? Now, to expand this using the Pascal's triangle, like I said, we have 1331, right? So what we are going to do is we are going to fix all these things to the product of A and plus B. Now the first thing we have is 1 and what? The first coefficient is 1. So we write down 1. So it's going to be 1 multiplied by A multiplied by B. Okay? So this is A and B. We are multiplying them. Just forget everything, and so that I will not extend the writing to where you cannot see it. So let me adjust my writing. So I'm going to start from here. All right, so we have 1 bracket A bracket inside the bracket. All right, okay, then plus, then we pick 3 brackets A brackets B. Like I said, forget anything for now, just bring them out. Then we have the next 3. So write plus 3 brackets A brackets B. Then we have 1 remaining. So that 1 is plus 1 bracket A bracket B. I don't know if you can still see that. Okay, now if you look at this, we need to start adding the powers of our A and B, A and B, A and B, and A and B. Okay, let me write this here. The last one is plus 1, this one, plus 1 bracket A bracket B. Okay, all right. Now, look at this. We start fixing our powers. We are going to start from 3 because this is raised to the power of 3. So we are going to start fixing our powers from 3. So our A will be raised to the power of 3. Now, once our A is raised to the power of 3, our B becomes 0. Now, why and how do I know that my B should be 0? I know because whatever powers I have here, if I add the 2 together, 2 of them should give me 3. Okay? 2 of them should give me 3. Now, I have A to the power of 3 already, so it's only 0 that I'll add to 3 to get 3, which is the power we are given. Alright, so that is why I knew that B is going to be raised to the power of 0. Now, coming to the next term, our A will now be 2 because we've written A to the power of 3. So we are going to write A to the power of 2 this time. So we'll have A to the power of 2. Now, 2 plus what will give us 3? 2 plus 1. So that means our B will be raised to the power of 1. I hope I'm clear. So our B will be raised to the power of 1. Now, coming to the next one, our A is raised to the power of 2 here, so our A will be raised to the power of 3. So I would suggest you forget your B. Always remember, continue to decrease your powers from the first term. So if I have A to the power of 3, the next should be A to the power of 2, the next will be A to the power of 1. Alright? And the next should be A to the power of 0. Okay? Now you can easily add the power of the other term by checking, because this is raised to the power of 3. 0 plus what will give us 3? 3. That means my B is raised to the power, should be raised to the power of 3. If I look at this one, this is A to the power of 1. That means my B should be raised to the power of 2, because 2 plus 1 will give me 3. 3 plus 0 is 3. So you can see how easy it is. Very, very easy. Yes, if this is the first time you are putting your mind to this, you may not really understand it immediately, but I'm telling you, it's the easiest thing you can ever do in mathematics. So we are going to do another example, but let me finish this first. If you have a question, you can answer me. Hello, Moise Boyden. The picky is glitchy. I can't see what you are writing from here. Okay, I think the only way out for YouTube is, please guys, I need to stop. Okay, and then, excuse me, I don't know, people are complaining that they can't see, but I have 21 people on board already. Okay, so let's continue, please. Now, if you look at this, we go ahead and solve. One thing you should always remember is 1. Okay, any number raised to the power of 0 is 1, or any term raised to the power of 0 is 1. Now, for example, here we have 1 multiplied by A to the power of 3, which is A to the power of 3. Okay, then B to the power of 0 is 1. So I don't need to add it anymore, because B to the power of 0 is 1. Okay, now plus we have 3, then A to the power of 2 is still A squared, and B to the power of 1 is still B. Alright, so the second term will be 3A squared B. Alright, then plus This one will be 3. Now a to the power of 1 is a, and b to the power of 2 is b squared. Then plus, if you come to the last term, you will see that a to the power of 0 is 1. So we have 1 times 1 is 1. Okay? Then that means we are left with b to the power of 3. So we have b to the power of 3. And this is the answer. So this is where the identity that a plus b to the power of 3 is equal to a to the power of 3 plus 3a squared b plus 3ab squared plus b to the power of 3. This is where it's coming from. Okay, so it's actually very, 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 very easy. Do you have any question? Any question from the viewers? Any question from the viewers? Please, I can't see. I don't really know what to do, seriously. I don't really know what to do. Any question from the viewers? Hello? No question? No question? No question? Charles, thanks for the share. I appreciate. All right. Now, if you have negative, that is, you have a minus b to the power of 3 instead of a plus b to the power of 3. The only difference between the solution you are going to get and what you have here is the signs. So if we have a minus b raised to the power of 3, this is going to be a to the power of 3. You start with minus, then you interchange the signs. Okay, this is what I mean. Now you have minus 3a squared b, then plus 3ab squared, then minus b to the power of 3. Always start with minus, no matter the power. Whether the power is an even number or an odd number, start with negative. Okay, so I'm going to expand this and show you why. Your answer is a to the power of 3 minus 3a squared b plus 3ab squared minus b to the power of 3. Okay, now I'm going to explain by expanding this. So let me clean this and expand this as if to say I don't know that this is what I will get, so that you see why the signs are interchanging. For the fact that this is negative, okay, the most important thing is the power. All right, for the fact that the power is 3, the coefficient should be 1, 3, 3, 1. Okay, if you are just joining, we've already drawn the Pascal's triangle. We have learned how to draw it as well. So this is where we picked this from. All right, so we have 1, 3, 3, 1 as the coefficients. So we are going to start with 1 multiplied by a multiplied by, now this time is going to be minus b, not just b, because what we have inside the bracket is a and minus b. Unlike this side, we have a and plus b, which is why I wrote a and b. Okay, but this time, if you want to expand this, this is minus b. That is what we have here. All right, then plus, remember that it is 1, 3, 3, 1. So it's going to be plus 3 brackets a brackets minus b. Then plus 3 again, this 3 brackets a brackets minus b. Then plus 1, this one, brackets a brackets minus b. Okay, Now remember that starting from the highest, now this is 3, so the highest power is 3. So you are going to write a to the power of 3 here, a to the power of 2, a to the power of 1, and a to the power of 0. That is the first thing you need to do. A to the power of 3, because this is what the highest power. So it's going to be a to the power of 3, a to the power of 2, a to the power of 1, and a to the power of 0. Now, because the power is 3, how do you know what the power of minus b should be? It's simple. When you add 3 to what will you get? 3 is 0. So if I add the two powers, the sum must be equal to 3. It shouldn't exceed 3. That is the logic. Okay? So instead of you to start fixing both of them and you make mistake, I would advise you fix the first power down. You fix your power on the first term and continue to decrease until you get to the last part, which should be 0. Then whatever you are going to add to the other power, on whatever the power should be, this one, the next term, each power, when you add it to the other one, everything should be equal to whatever power you have here. So this one is 2, so 2 plus 1 is 3. Then coming to this one, 1 plus 2 is 3. Coming to this one, 0 plus 3 is 3. So it's going to be a to the power of 3 minus b to the power of 0, then a to the power of 2 minus b to the power of 1, a to the power of 1 minus b to the power of 2, a to the power of 0 minus b to the power of 3. Okay? Alright, now let's analyze it. Adebayo Bamidele, thank you so much. So now let's analyze it. Okay? Or let's simplify it, sorry. So a to the power of 3 is a to the power of 3. So we'll write that. Now remember that any number raised to the power of 0 is 1. So if I multiply minus b and raise, if minus b to the power of 0 is 1, so we have a to the power of 3 here, because a to the power of 3 times 1 will still give me a to the power of 3. Alright, then plus, here we have 3 a to the power of 2, but remember that we have minus b to the power of 1. And minus b to the power of 1 is still minus b, okay? So we have brackets minus b here. But remember that we have minus and plus here. Plus times minus will give you what? Minus. So that is why this sign will change. And we now have a squared multiplied by b. Because when you open these brackets, you have minus b. So this minus times this plus is minus. So it's definitely going to have changed this plus sign to minus sign, which is where the first negative sign is coming from. When I told you that that is plus, here we have 3. Now a to the power of 1 is still a. This time we have minus b to the power of 2. Minus b to the power of 2. This is the same thing as minus this same thing as minus 1 times b, right? So that minus squared will give you plus. And b squared is b squared. So minus b squared is same thing as b squared. So you notice that we have b squared here. So it's not going to affect this plus. So we have b squared here, which is why this sign retains its positivity. I hope I'm clear. That is why it retains its positivity. Oh, people are seriously saying that they can't see the video. All right. Now we are done with this one, right? So let's go to this side. When you come to this side, we have plus. Then a to the power of 0 is 1. Why? Because plus minus is minus. You don't need the two operators lying side by side. So instead of me to write plus minus b to the power of 3, I'll rather write minus b to the power of 3. So that is where the answer comes from. You notice that this actually changes. My colleague, thank you so much. Thank you so much. So we have a to the power of 3. You can see that the signs are changing, which is why I said when you are giving something to expand and you have negative sign, you don't need to stress yourself trying to expand it this way. Just write your, and whatever you want to write and interchange the sign. Whether your power is even or odd, the sign will start from negative, positive, negative, positive, negative, positive. It will keep interchanging each other. Okay, so that is it for this particular one. That is it for this particular one. Now, do we have any question? Do we have any question? Any question? Do we have any question? Any question from anyone? Okay. Now, what if the power is 4? What if the power is 4? For example, we have a plus b to the power of 4. So a plus b to the power of 4. Let me fill this ink. It's becoming faint and faint and faint. Any question? Any question? Okay. So let's talk about the fourth power. Now remember that in your Pascal's triangle, for the benefit of those that joined us late, I'll just rush through it quickly. You can then at your convenient time look for try to understand it, maybe browse it or something. So according to the Pascal's triangle, you start like this. 1 plus 1 is 2. Write the 2 between the two numbers you added. Then complete again with 1 and 1. Then for the next line, we have 1 plus 2 is 3. 1 plus 2 is 3. You can see that the number I'm adding together, the sum, I'm writing it in between the two numbers. So you complete again and again with 1, 1. So this is for power 3, which is where we got 1331 that we've been using all this while. Now we are giving to the fourth power. Okay, so it's going to be 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Then I have 1, 1. So it means that the coefficients are going to be 1, 4, 6, 4, and 1. So I'm going to write it somewhere. 1, 4, 6, 4, and 1. So that it will guide me while expanding this expression. Alright. Now, let's go ahead and expand. So, remember that you just multiply the two terms you have and add the coefficients before them. That's the first step. So, let's go ahead and do that. So, it's going to be 1 multiplied by, sorry, I'm trying to go back a bit so that I'll have enough space. So I'll have 1 multiplied by A multiplied by B. So that is it for this one. Then the next one is 4. Okay, so we go to plus 4 multiplied by A multiplied by B. Then we have 6 plus 6 multiplied by A multiplied by B, plus we have 4. Okay, so we have 4 multiplied by A multiplied by B. Then we have 1 multiplied by A multiplied by B. So what we just did is simple. What we just did now is very simple. All we did is that we added these coefficients: 1, 4, 6, 4, and 1 to the product of the two numbers or the two terms we have inside the bracket, which is a and b. So that is why you have ab, 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 ab for both of them. So this is the first thing you need to do. It's going to be, this is a to the power, this is the power of 4, that is the highest power. The power is 4. So we are going to start with a to the power of 4, then we go down, a to the power of 3, a to the power of 2, a to the power of 1, and a to the power of 0. Very easy, right? A to the power of 4, a to the power of 3, a to the power of 2, a to the power of 1, and a to the power of 0. All right. Now, after that, you need to write the power of the next term. In this case, our next term is b. Now, how do you know the power of the next term? Whatever you are going to have as power of the next term, when you add it to the first one, it should be equal to what you have here. Now, the highest power is 4. So, what I should write here is b to the power of 0. Okay? So, because 4 plus 0 will give us 4. Now, we have 3 here. 3 plus 1 will give us 4. We have 2 here. 2 plus 2 will give us 4. We have 1 here. 1 plus 3 will give us 4. And we have 0 here. 0 plus 4 will give us 4. Very easy. As easy as A, B, C, D. So sometimes when students complain of the Pascal's triangle, I used to imagine like, why is it really hard? Because it is very easy. So the next thing we now need to do is to just analyze this. Okay? Sorry, to simplify it further. The only thing I always say is remember that any number raised to the power of 0 is 1. Any number raised to the power of 0 is 1. Okay? So what should I do now? All I'll need to do is a to the power of 4 times 1 will still give me a to the power of 4. But b to the power of 0 is 1. So 1 times a to the power of 4 is still a to the power of 4. So that is what I'm going to get here. Okay, so if I simplify this, I'll get a to the power of 4. As easy as that. Now to the next one, we have plus 4. A to the power of 3 is a to the power of 3. And b to the power of 1 is b. You can see, very easy. So we are done with the second one. Then to the third one, we have plus 6a squared b squared, right? A squared b squared. Plus. Now to the next one, we have 4. Then a to the power of 1 is a. And b to the power of 3 is b to the power of 3. Plus. Now the last one, remember that a to the power of 0 is 1. So what we have here now is 1 times 1, which is 1. Right? So we are left with just b to the power of 4. B to the power of 4. And this is the final answer. The final answer is a to the power of 4 plus 4a to the power of 3b plus 6a squared b squared plus 4ab to the power of 3 plus b to the power of 4. As easy as that. All right, do you have any question? Any question? Any question? Let me see if I can fix this. Seriously. Okay. Now, any question? No question? All right, so are you ready for a classwork? Maybe I should just ask you to do something. Are you ready? Who is ready? So if you know you've been here for a while and you actually understood what I did, can you do this for me? X plus y raised to the power of 4. Can you expand this for me using the Pascal's triangle? x plus y raised to the power of, okay, let me say raised to the power of 3 so that you can do that faster. X plus y to the power of 3. Wow, it's really simpler. Thank you. Yeah, you're welcome, darling. You're welcome. I'm not just that happy because most of you are saying that you cannot see the board clearly. So I might actually repeat this topic next time for the benefit of most of you that are not able to see the board. So, but those that are able to see it, I'm really happy. So guys, let me know. Can you do this? This one that I wrote. Can you do that? Can you do that? Dun, 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 dun. No one is replying. Can you do that? I can do it. Okay, sample, tell us the answer that you got. Have you expanded it? Expand and tell us the answer. Let's see. Expand and tell us the answer. Expand and tell us the answer. Shane and Mary Mama. Dun, dun, dun. Dun, 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 dun. Dun, 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 dun. Who is with me? Who is on the question? If you know you are solving the question, let me know. If you are solving the question, let me know. Should I wait or should I solve it so that everybody will see it and compare with what you solved yourself? Should I solve it or what do you think? Who has solved it? Or who have expanded it? Who has expanded it? What's your solution? What's your answer? What's your answer? What is your answer? Or maybe we should change the time of the class to maybe in the morning. Maybe morning time. Okay, since no one is doing it. Okay, someone said I should please do it. Alright, now let me do it. Okay, this is for the benefit of those that joined late, and most of you said you couldn't see the board even when I was trying to, when I was teaching how to get the Pascal's triangle. Okay, so because of that, let me do it. Now remember, in fact, what I personally do is when I have something like this, when I know that I want to expand an algebraic expression using the Pascal's triangle, I don't cram the Pascal's triangle. No, I have a lot on my head already to start cramming anything. So I try to understand it. But I was able to cram the third line. The third line is easy, which is 1, 3, 3, 1. That is the third line. 1, 3, 3, 1. Okay, so I know that with this I can get the fourth line, the fifth line, the sixth line. It's very easy, right? Because for the fourth line now, I'll just say 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and I'll complete 1 1. Then I'll just continue depending on the power of the question that I was given, the power of the algebraic expression I was given. Okay, but this time around, this is very easy. To the power of 3 is very easy. Okay, so it simply is 1 3 3 1. This is the coefficients, 1 3 3 1. Now let's make use of it and solve. So I'm going to write it somewhere. 1 3 3 1. These are going to be the coefficients of the expressions. So this is what I will do now. Okay, like I said, you are going to multiply whatever you have inside your bracket with the coefficient. So the first coefficient is 1, so it's going to be 1 multiplied by x and multiplied by y. Like I said, you will make mistake if you try to do everything together. So the first step is I will advise you can still do it your own way. This is how I do mine. Okay, the first step is I just write multiply everything first, including my coefficient. So this is 1 multiplied by x multiplied by y, plus then I'll have 3 multiplied by x multiplied by y. X and y are this and this, the two things you have inside the bracket. Do you understand? All right, now I have plus 3 again, 3 brackets x brackets y, and I have 1 plus 1 bracket x bracket y. That is the first step. That is the first step. Then what do I do next? Very easy. What I will do now is, this is the highest power, which is 3. Okay, just write that power as the power of your first term. Now our first term here is x. That is our first term, so that is what will carry the 3. So I'll have x to the power of 3. Like I said, you can leave the other one first, just go down. All right, just keep going down. So I have x to the power of 3. This should be x to the power of 2. This should be x to the power of 1. This should be x to the power of 0. Then after 3, remember that the power we have here is 3, and we need what we can add to 3 to give us what? 3. Whatever you have as the two powers, the sum should be equal to 3, so which is 0, because 3 plus 0 is 3. Now you can start from 0, then go down, go up for y. Okay, so this is 0, this is 1, this is 2, and this is 3. So in essence, there are 2 ways you can fill this up without making mistake. 1, you start from 3 for your first term, okay, because this is raised to the power of 3 anyway. If it's raised to the power of 4, I'll start from 4. So because this is raised to the power of 3, my first term is x, so it's going to be x to the power of 3. Then I go down, x to the power of 2, x to the power of 1, x to the power of 0. Then for the next term, I'll start from 0 and go up. So it's going to be y to the power of 0, y to the power of 1, y to the power of 2, y to the power of 3. Then in another way, you need to understand why. Why do we choose to go down? That is because whatever we have as our powers, when we add both of them together, we must get 3. They must be equal to 3. Okay, so we have 3 plus 0 here is 3. You can see that. 2 plus 1 here is 3. You can see that. 1 plus 2 here is 3, and 0 plus 3 is 3. So that is the reason. There is no magic there. All right, now what do we do next? We go ahead and simplify. We go ahead and simplify. So to simplify now, we have x to the power of 3 multiplied by 1 is still x to the power of 3, right? And y to the power of 0. Please always remember, any number raised to the power of 0 is 1. Okay? Any number raised to the power of 0 is 1. Which is why y to the power of 0 is 1. So I'm going to ignore it, because 1 times x to the power of 3 times 1 is still x to the power of 3. Okay? So we are done with the first term. Now coming to the second term, we have plus 3. Now x to the power of 2 is x squared, and y to the power of 1 is y. We are done with the second term. You can see how easy this is, and that is because I didn't cram it. I tried to understand it from the scratch. That is understanding how to form my triangle without cramming the figures we have on each step. That is going to give you a big relief. Okay, knowing how to form your triangle, the Pascal's triangle 1. Then 2, knowing how to use it without stress. You don't need to cram it. Okay, Now let's continue. So we are done with this. Let's simplify this. So this is going to be plus 3 x to the power of 1 is x, and y to the power of 2 is y to the power of 2. Okay, so plus, here we have, remember, any number to the power of 0 is 1, which is why I have x to the power of 0 is 1, so I'm going to ignore it. 1 times 1 is 1. Now we have y to the power of 3, so plus y to the power of 3. That is what the last term will give us. And this is your answer. X to the power of 3 plus 3x squared y plus 3xy squared plus y to the power of 3. You can see how easy it is, right? Extremely, very, very easy. My organization is called ACE Academic Blam Blam Blam. Okay, all right. So any question, friends? Do you have any question? Do you have any question? I'm here. Ask me your question. Ask me your questions. Do you have any question? Let me stand here so that you can clearly see the board. Any question? Any question? Excuse me. Okay. All right. Now, I believe you all are. I know about Pascal's triangle already. My interest is calculus 3 and linear algebra. All right. How does a typical wire question appear? We will get to that. Now, someone is asking, can't we, the question is, can't we simplify this further? Of course, you can simplify this further if you want to. Do you understand? Now, how do we simplify it further? We can write x to the power of 3. Now, when you look at this term and this term, you bring out their common term. So to bring the common term out, I have plus. They have 3 in common, I'll pick 3. They have x in common, I'll pick x. They have y in common, I'll pick y. Then I'll open my brackets. Okay? So 3x squared y divided by 3xy. We are left with just 1x, right? Plus 3xy squared divided by 3xy. We are left with just 1y, right? Then plus y to the power of 3. So this is what you can get as well. Do you understand this? Because if you open this bracket, 3xy times x will give you 3x squared y, plus 3xy times y will give you 3xy squared. So you either leave it like this or you simplify it further in this way. That's all. That is the highest we can do. All right. So Ahmad Langat, hope that is clear. Hope that is clear. I've already simplified it like you said. I'm sorry about the visuals and everything. I'll try to see what I can do about it in our next meeting. So by the grace of God, our next meeting, the visual will be better than this. I know that some part of the